Okay, so our last property that we're looking at is the power property of logarithms. So again, I always like to go back to normal exponents. So remember, this means x squared times x squared times x squared, and these each are 2x's. So the answer is x to the 6. What's the shortcut? We multiply our exponents. So when I'm raising a power to a power, I multiply, okay? So same idea with logarithms. If I have log base 4 of x squared, anytime I have an exponent within the argument, so the thing I'm taking the log of, if there is an exponent on it, I can move it to the front of the problem and make it into a multiplication problem. So this one becomes 2 log base 4 of x, okay? So what I would like you to do in your notes is try this one. If I have log base 5 of 4 to the third, what could I do with that 3? Rewrite this one, moving that 3 out of the exponent for me. Okay, now we're going to kind of try and put this all together. So we're going to take all of our properties here and use them. So if I have this problem right here, and I asked you to expand this problem using the rules of logarithms, okay? So the first thing I'm going to do is I'm going to notice that I have a squared here, but this squared is only on the x and the y because it's on these parentheses here. It does not cover the z there. So I'm not going to worry about that yet. I'm going to go ahead and break apart this division. So I'm going to say log base 3 of x y squared minus log base 3 of z. Okay? So that's coming from the fact that this was division, and we know with the properties of logarithms, the quotient property tells me that I can turn that into 2 logarithms that are being subtracted. Okay? This one's good. There's nothing else I can do to z, but this one I can do more to. So first I'm going to take that squared. We just learned that the power property tells us we can move the exponent to the front. So this becomes 2 times log base 3 of xy, okay, minus log base 3 of z, okay? The next thing would be to pull this apart. So still, this is not completely simplified. So I could pull this apart. I'm going to say 2 log base 3 of x plus 2 log base 3 of y. Now, why did I do that? This was multiplication. So when I use my multiplication, my product property, I know that I can break that apart into 2 logs being added. They both have the 2 on them. Now, why do they both have the 2? Because wasn't the squared both on the x and the y? Yes, it was. And then I'm going to go ahead and bring down this that I already had. And you notice this one does not have a 2 on it. It doesn't have a 2 on it because it didn't have a 2 on it in the beginning. Now, each one of them, this one just has an x, this one just has a y, and that one just has a z. So this is completely pulled apart, okay? So what I would like you to do is I would like you in your notes to try on your own to do this one. Log base 2 of AB over C squared. I want you to try and pull that one apart into multiple logs. A little hint, this 2 is on everything now. So I suggest you pull that forward first, then break it apart based on your division, then break it apart based on your multiplication. Your answer will have 3 terms to it. Okay, so go ahead and try that one in your notes. So that's something that I can look at to see that you understand.